Okay, I thought we could take a look at one of the exercises from section 2.2. So that's where I got this. So this is from section 2.2. This is problem number 2, and it's on page 100. So we have a function here. F of x is equal to 3 times the cosine of x minus 2 times the sine of x plus 6. And we want to find the slope of the tangent line to f at the point where a is equal to pi over 4. So that is the problem. Okay, so here's the problem, and this is, again, problem number 2 in section 2.2. And I've kind of added a little bit here. We're not only going to find the slope of the tangent line, but we're also going to give the tangent line's equation, and we're going to graph it. It's going to be awesome. To find the slope of the tangent line, you know what we need to do. Take the derivative. So the function is here, and so we'll just differentiate piece by piece. The derivative of cosine is negative sine. So the first term will be negative 3 times the sine of x. The derivative of sine of x is cosine, so the next term will be 2 cosines of x. And the constant on the end, of course, we're going to lose that when we differentiate. So here's the derivative, and now we just need to plug in our point, which is given as pi over 4. So negative 3 times the sine of pi over 4 minus 2 times the cosine of pi over 4. The sine and the cosine of pi over 4 are both equal to root 2 over 2. So negative 3 times root 2 over 2 minus 2 times root 2 over 2. That makes negative 5 of them altogether, right? And so this is the slope of the tangent line. All right. So that answers the first part of the question. The second part of the question that, again, I have added is to give the equation of the tangent line. So we have the slope. We just need a point. We know that the x part of the point is pi over 4 because it was given to us right there. We just need to find the y part of the point. So how do we do that? We take the x part of the point and plug it into the function. So f of pi over 4 is 3 times the cosine of pi over 4 minus 2 times the sine of pi over 4 plus 6. These things are still equal to root 2 over 2, so we have 3 times root 2 over 2 minus 2 times root 2 over 2 plus 6. So we have 3 of them here, minus 2 of them there, leaves the other one. So the y part of the point is square root of 2 over 2 plus 6. So if we take all, so that's the y part of the point, square root of 2 over 2 plus 6. So if we take all this together and plug it into the equation for a line, so I'm going to use this one, y minus y1 is equal to the slope times x minus x1. So y minus the y part of the point, root 2 over 2 plus 6, that's supposed to be equal to the slope, that's this part, 5 times radical 2 over 2 times x minus the x part of the point is pi over 4. And I'm going to put this in the calculator, so I'm going to add this part over to the right, so I just have y equals, and there's really no point in trying to simplify this. We can just enter it into the calculator as it is, root 2 over 2 plus 6. So let's go see what it looks like on the graph. So here we have, this is actually the graph of the function f. So if you look at y equals, excuse me, it's 3 times the cosine of x, so this is f, right? So, and if you're playing along at home and you want to see how I have the window set, it's going from negative pi to 2 pi, and then the y part of the window goes from 0 to 12. But what we want to do now is we want to plug in our equation for the tangent line. So if I can get down here. So this is the work that we just did. So we want the slope. So negative 5 times the square root of 2 probably parenthesize all of this, divided by 2 times x minus pi over 4. And then we want to add on to that the square root of 2 over 2 plus 6. Square root of 2 divided by 2 plus 6. I'm going to go ahead and arrow up here and make the original function bold so that we can tell the difference between the two of these things. So the curve will be in bold and the tangent line will be not in bold. Okay, here we go. Cross your fingers, ready, go. So there's f. I put the tick marks at pi over 2, so pi over 4 is right about here. So we should see the tangent line coming through right about here. Oh my God, look at that. Is that awesome or what?